All right, so this video will cover two examples of applying the first derivative test. And we're in section 3.3. So the strategy for applying the first derivative test is very similar to the other video where we determine intervals of increasing and decreasing. So first we're going to find its derivative, f prime of x. And then second, we find any critical numbers. And then third, we're going to find intervals of increasing or decreasing. And to do that, so to do step 3, when we're determining intervals of increasing and decreasing, this is what the previous video covered, but in summary, we first determine the intervals based off the critical numbers. All right, then you pick a test value for each interval. Test values from each interval. And then you plug each test value into the derivative. All right, so f prime of x, if it's positive, then it's increasing. And then if it's negative, then it's decreasing. All right, that's for step 3. I just didn't want to have to write so much for that, make it less cluttered, but essentially define the intervals of increasing and decreasing. Like in the previous video, we first determine the intervals themselves based on the critical numbers, and then you pick a test value from each interval, plug the test value into its derivative. If the derivative results in a positive number, that's going to be increasing for that interval. If the derivative results in a negative number, it's going to be decreasing for that particular interval. All right, after you determine that, the intervals of increasing and decreasing, you're going to decide whether the critical number is a relative max or min. And relative max just so we're on the same page here. So here's a graph where you have a relative max. So you have C, and that occurs right there. So it's going to be increasing to the left of C and then decreasing to the right of C. So it goes from increasing to decreasing for relative max, which means its derivative, f prime of x, goes from positive to negative. And it's the opposite for relative min. Okay, so it's going from decreasing to increasing. Another, based on its derivative, that means it goes from negative to positive. Right, that's how you're going to determine whether it's a relative min or relative max. So that's the specifics for step 4. The last thing we do is, after you determine whether that critical number is a relative max or min, you need to find the y coordinate that corresponds with that max or min. And make sure you plug it into the original function. This is key. you do not plug it into its derivative. That would give you 0. That would defeat the purpose. All right, so those are the steps. In general, find derivative, find critical numbers, determine the intervals of increasing, decreasing, determine if it's a relative max or min based on the switch of signs for the intervals and its derivative. And then last, you find the y coordinate that goes with the relative max or min. All right, so I'll be working these 2 examples in this video, and then I'll do 2 more examples in the next video that will be trigonometry, like involving trig functions. All right, so number 19. All right, so first thing we need to do is find its derivative. So f prime of x. Derivative of x squared is 2x by power rule. And then it'll be minus, and then 8 times 1, because the derivative of x is 1. So its derivative is 2x minus 8. All right, now I'm going to determine critical numbers. And I'll circle this derivative because I'll have to use this later when I'm determining increasing, decreasing intervals. All right, so find the critical numbers. That's what I'm going to do now. And it's either the derivative doesn't exist or it's set equal to 0. 2x minus 8 is a polynomial. Specifically, it's a line with slope 2, y-intercept -8. So it's continuous everywhere and its derivative exists everywhere. So there are no x values for which its derivative does not exist. So we only focus on setting its derivative equal to 0. So f prime of x, you set that equal to 0. So you have 2x minus 8 equal to 0. You add 8 to both sides. You have 2x equal to 8. And then you divide by 2. So 8 divided by 2 is 4. All right, and our critical number is 4. And so I'll say use the letter C for that. Now I need to determine the intervals of increasing, decreasing. So I'm using I and C for increasing and then DEC for decreasing. As a visual, again, you don't have to do this, but if you want to draw it out, so you have a number line and then you have 4 is your critical number. So I have 2 intervals that I need to test. So I have the interval that goes to the left of 4. That's from -infinity to 4. And make sure I use parentheses around the critical number. And then I have the values that are, the interval is to the right of 4. So that's 4 to +infinity. And then I pick a test value from each interval. All right, so intervals. -infinity to 4. 4 to +infinity. Then I pick some test values. 0, if you could pick 0, that's always a recommended test value. It's easy to plug in. So I'm using x1 is 0. And then I'll use 5. That's to the right of 4 for the other interval. All right, so those are my 2 test values. I need to plug these into the derivative. And the derivative, I circled it, f prime of x is 2x minus 8. All right, we only care if it's going to be positive or negative. The sign is what matters, not the actual value itself. so for 0, when you plug in 0 into its derivative, we're plugging it into this, so that's going to be 2 times 0 minus 8. Well, that's minus 8, right? So that's going to be negative. So this is going to be negative. And the value, negative 8 itself doesn't matter, it's just the sign. So I know for this test value it produced a negative first derivative. What does that mean? That means the function is going to be decreasing. And that occurs under the interval negative infinity to 4, since that's where my test value came from. All right, now the other test value is 5. That's going to be 2 times 5 minus 8. So that's 10 minus 8. That's going to be positive. All right, so it's positive for that interval. And since it's positive, that implies it's going to be increasing. And that's on the other interval from 4 to positive infinity. All right, so those are my intervals of decreasing and increasing. And I'll just box those. All right, now I just need to find if the critical number is a relative min or a relative max. So now determine if c equals 4 is a relative min or max. So we said to the left of 4, it was decreasing. And so here it was decreasing, so it means it's going down. To the right of 4, it was increasing, so that was positive. So it's going up. So since it goes from negative to positive, for its derivative, that means I'm going to have a relative min. All right, and now I just need to find, well, what is the y-coordinate that goes with this relative min? In other words, what is the relative min itself? So last, find the y value or y-coordinate of the relative min. And we do this by plugging it into the original function. That's the key here. So to do this, you must use the original function. We're not plugging it into the derivative, because if we did, it would give us 0, because that's a critical number. So use original function. So we have a relative min, and it's at c equals 4. The function, original function is x squared minus 8x. So plugging in 4, that's going to give us 4 squared minus 8 times 4. So 4 squared is 16, 8 times 4 is 32, so you have 16 minus 32, which is negative 16. All right, so now we've determined finally our answer. Finally, based on first derivative test, the relative min is the point 4 comma negative 16. All right, so our input was 4, our critical number, and then our output was negative 16. All right, so that is the process for first derivative test. All right, so it's the first several steps are the same as the previous video, just finding the intervals of increasing and decreasing. That's all from the same from the previous video. It's just now from that knowledge, we determine the relative min or max based on the sign change. In this case, it went from a negative to positive or decreasing interval to an increasing interval, which means we have a relative min. And that is that our critical number C equals 4. And last, we just need to find, well, what the actual relative min is. And that's plugging it into the original equation, original function. So you get negative 16 for the y coordinate of the relative min. All right, so that's that problem. This next one's number 27. The same thing that we're going to do. All right, so this is the function. I go ahead and write it differently. So you could write it as x over 5 over 5 or minus 5x over 5 based on adding and subtracting fractions. And I could write this as 1/5 x to the 5th and then minus x because the 5's divide out. All right, so I just went ahead and rewrote it like that, and now I'm going to find its derivative. So find f prime of x. So that's going to be equal to 1/5 times the derivative of x to the 5th. You drop down the 5, so it's 5x to the 5 minus 1. That'll be 5x to the 4th. And then minus x, that derivative turns into 1, so it's minus 1. And then the 5's divide each other out, so you have f prime x to the 4th minus 1. All right, that's the first derivative. Now I'm going to find critical numbers. Okay, so this is a polynomial. Like we said multiple times now, polynomials are continuous and differentiable. There's no case in which its derivative doesn't exist. So I only need to focus on setting it equal to 0. So find x, where f prime of x equals 0. So I set x to the 4th minus 1 equal to 0. Now I would factor this. So to factor it, I use the difference of squares factoring formula. And you could write this factors in the x squared minus 1 times x squared plus 1. Now the x squared minus 1, I could still factor that. So that turns into x minus 1 times x plus 1. All right, so these are my factors. I can't factor x squared plus 1. Okay, so then I determine the critical numbers by setting each factor equal to 0. right, so x minus 1 equal to 0, that gives me 1. X plus 1 equal to 0, that gives me negative 1. Now the x squared plus 1, if you set that equal to 0, just to show, since it doesn't factor, there isn't going to be an x value for which this holds because it'll be an imaginary number, right? Because you'd have x squared equals negative 1. And that doesn't help us because it's a negative number. So I would say no real number squared is negative. And we're in calculus, we only deal with real numbers. So I ignore this one. Okay, so I have these two values are my critical numbers. All right, so critical numbers are 1 and negative 1. So I'll use C1 for the first one and negative 1, and then C2 for the other one, positive 1. So I just listed the negative 1 first. Okay, so far I rewrote the function so that it's easier to find its derivative. I found its derivative. It was x to the 4th minus 1. Then I determined the critical numbers, and that involved doing all this factoring. And that's where I used a factoring formula. Because of x to the 4th minus 1, you could think of that as x squared squared minus 1 squared. So it's a difference of squares. So that's why I factored in x squared minus 1 times x squared plus 1. But then the x squared minus 1 itself can be factored. So that's why I have x minus 1, x plus 1. But the x squared plus 1, there's no factoring formula for that. All right, then I set each factor equal to 0. So you get 1, negative 1. The third one doesn't give you a real number since it's x squared equal to negative 1. And we only deal with real numbers for calculus. All right, so I ignore the third case and I just have 1 and negative 1. All right, so I have my critical numbers. Now I need to find the intervals of increasing and decreasing. So find intervals of increasing and then DC for decreasing. And I like to first, we got to find the intervals that we're going to use. So again, this isn't necessary, but I draw a number line. So you have negative 1, we have 1. So our possible intervals. You have everything that's to the left of negative 1. That's negative infinity to negative 1. You have everything that's in between negative 1 and 1. All right, so that's negative 1 and 1. And then everything that's to the right of 1. So that's 1 to positive infinity. If I have 3 intervals, I need to find if they're increasing or decreasing. All right, so the test values. All right, so for a value that's to the left of negative 1, I'll use negative 2. And then a value that's between negative 1 and 1, I'll use 0. And then a value that's to the right of 1, I'll use 2. So I have x1, negative 2, x2 is 0, x3 is 2. All right, now I plug these into the derivative and determine the sign. And the derivative, so again, I circle the derivative just so I have to reference it, x to the 4th minus 1. So plug these into f prime of x equal x to the fourth minus 1. All right, so for the first one, where it's -2. So that's -2 to the fourth minus 1. Now, because this is an even exponent, this -2 thing, -2 to the fourth power, that's going to result in a positive number. And it'll be bigger than 1. So you subtract 1 from a bigger number that's positive. This is going to still be positive. So this is positive. So I think 2 to the fourth is, let's see, 2 to the eighth is 8, and then times 2, 16. So I think that's 16 minus 1, which is 15. And again, anytime you have a negative number in parentheses raised to an even exponent, that's going to equal a positive number. All right, so that's just to remember that. People will put it in their calculator without the parentheses, and it's absolutely crucial to have the parentheses. All right, so the next one. And I used 0 for x2. Okay, so this will be 0 to the fourth minus 1. So that's 0 minus 1, so that's negative. Okay, so, all right, so let's see. So we have this is positive, that's negative. What does it mean to be positive? That means we have this interval -infinity to -1. It's going to be increasing I and C. This interval, we had it to be negative. For its derivative, that means it's going to be decreasing. So I use DEC. The last one's plugging in 2, and that's going to be positive because you'll get the same as the first case. You get 2 to the fourth is 16 minus 1 is positive 15. All right, so that's positive. So I'll put positive here, and then I and C for increasing. So in summary, as far as our intervals, again, we're not done yet. I'm just writing what the intervals of increasing, decreasing are. We have -infinity to -1, increasing, -1 to 1, decreasing, and then 1 to positive infinity was increasing. All right, so that's our intervals of increasing and decreasing. So I'll just box that since that's important. All right, so now we get to the first derivative test part. We need to find whether it's a relative min or max at each critical number. So we know to the left of -1, that was positive, so that was increasing. And then from -1 to 1, that was negative for our test values, that was decreasing. So it goes from increasing to decreasing, which means -1 is a relative max. And then for this last one, it was positive. So around 1, it goes from decreasing to increasing. So that's going to be a relative min. Okay, so relative max at the critical number -1, relative min at the other one, so that's +1. And again, first one's a max because to the left of -1, that interval is positive for its derivative, which means the graph is increasing, and then it switches to decreasing around -1, and then around 1 it switches from decreasing to increasing, so that's why that one's a relative min, and the first one's a relative max. Okay, so that's important, and we're finally to the last bit of this, is to find the y-coordinates that go with each one of these. So last, find the y values that go with each min and max. All right, and this is where you gotta get people get tripped up. You have to always use the original function. And the original function, well, I wrote it out different, but what it started out was x to the 5th minus 5x over 5 was what it started out with. All right, so I plug in each one. So for -1, that's going to be -1 to the 5th minus 5 times -1 divided by 5. Okay, so what that'll give me, the -1 to the 5th power, that's an odd exponent, which means that stays negative. So it's really -1. And then negative times negative is positive, so that'd be plus 5 over 5. So it's 5 minus 1 over 5. So that gives me 4/5. That's the y coordinate that went with the C1 being -1. So that's the point -1 comma 4/5. And then the second point, so that'd be 1 to the 5th minus 5 times 1 over 5. That's 1 minus 5 over 5, which will give me -4/5. That was the point 1 comma -4/5. All right, and we're basically done. We can now say by the first derivative test, and I'm using f dt, we have a relative max is the point -1 comma 4/5. And then relative min is the point 1 comma -4/5. All right, so that's it for this video. Obviously, you see these examples take quite a bit of time. And that's the first derivative test. It was basically the same stuff as the previous video. You just find the intervals of increasing and decreasing like before. And you need to determine whether you have a relative max or min based on if the graph goes from decreasing to increasing or increasing to decreasing. All right, so the next video I'll do some involving trig functions.